Hello, my name is Arthur Bedford, and today I'll be talking about my future profession as a cannabis extraction technician. And for some of you who don't know, there are a variety of different techniques used in cannabis extraction in order to get the different desired outcomes, such as like shatter or distillate, or just different forms of an end product. Now, cannabis plants are home to over 113 different cannabinoids. And what cannabinoids are chemicals that specifically pertain to cannabis plants that are unique to them. And as they're also home to as well as 550 different chemicals. Now, it's the job of the extraction technician to extract the chemicals desired, which can be done by an alcohol solvent, which is most common, and it's done by soaking the cannabis in the solvent, the alcohol, usually ethanol. Then the plant material is removed, the liquid is filtered, and the alcohol is removed by some sort of evaporation. Now, amongst the research community, like within your research department, within your company, it is the job of the extraction technician to speak to the researchers, because the researchers will tell them like these are the parameters that you need to run this by, like this is what we're looking for. And I'm only going to touch on this briefly, as my interview with my organic chemistry lab instructor is going to touch on this a lot more, on the whole extraction process, as well as the communication required between the research team as well as the extraction technician team. Thank you. And without further ado, we will now be listening to the interview I had with my organic chemistry lab instructor, Paul Savoy, or Dr. Paul Savoy.
Okay, so when it comes to extracting cannabinoids, there are really two aspects to this. There's the technician end, and then there's the research end. If you're going to be a technician, you're more or less the grunt, for lack of better terms. You are working with materials and equipment that are already known. The conditions have been worked out. You're really more or less monitoring the work that's ongoing. The research folks, they're the ones who dedicate a lot of time and energy into finding the correct conditions for extracting whatever compound you're looking to extract from whatever medium from which you're obtaining it. So there's this interplay between the two. The researchers work out the conditions and the equipment, and then the technicians are the ones who do the work in the lab, they monitor the results, and occasionally there's this interplay where the technicians come back and they say, hey, look, we've been getting these sorts of yields and these sorts of values during our work. The research has been saying that we should be obtaining these sorts of values and yields. So, okay, things aren't working exactly as they should be. So then what's the problem? And then they kind of work together to sort it out. The researchers might go back into the research lab and do some more tests. And then they'll report back to the technician, okay, tweak these parameters and you should be good to go. So all that aside, now we can actually get to the meat of the matter when it comes to extraction. And here the conditions matter. So there are many different ways to do an extraction. For example, you could do a liquid-liquid extraction. That might be helpful for pulling out, say, caffeine from tea. Or if you're looking at more like cannabinoids, okay, you might get involved with SOxLit extraction. If you really want to go fancy, you could go to something like supercritical CO2, but the problem there is the cost. You need stainless steel reactors, extractors, and things like that, and that comes at a high premium. Other sorts of things like SOxLit extractors, well, that's made out of glass, and you can do that in the lab. Separatory funnels, same thing. It's all made out of glass, really not that specialized. But where you can get into some trouble, for example, is if you need to perform an extraction with, say, butane or propane. Now, we normally think of those as gases, but under the right conditions, you can liquefy them. You really got to press on them to get that to happen, but it can be done. That's where your stainless steel equipment comes in. Otherwise, you might say, well, I want to extract this compound and I can do it with, say, toluene or ethanol. That too is perfectly fine. And so then you can say, if I'm going to work with liquid reagents, I can use glass. If they're otherwise a gas under standard conditions, I need to use stainless steel. So that's why I said the conditions matter. The extraction material determines the type of equipment you need. But then let's say you do the extraction. Well, you don't want to have, let's say you're doing it in toluene, you don't want to have your product sitting in a bunch of toluene. And toluene is better known around the house as paint thinner. So you want your plant extract. You don't want paint thinner in there. So then, okay, we've extracted our compound from the material, but how do we separate our desired compound from the solvent? Well, that's where distillation comes in. And depending on the scale and the type of reagents you're working with, you might be able to use just a simple distillation, which nowadays you would do on a rotary evaporator, which is all pretty straightforward. Or if the boiling points are a little too close to one another, or if you have a volatile plant extract, for example, say propane thiol S oxide, which is the characteristic compound that causes your eyes to water when you cut onions. That's a gas, or a liquid that turns into a gas, rather. Well, distillation might not be as straightforward, so then you go to a fractional distillation, where instead of just one step, you can vaporize the liquid and collect it somewhere else. Now you say, okay, I need to vaporize the liquid a little bit and have it recondense, and then vaporize, recondense, and every time it goes through the cycle, the compounds separate a little bit more. Ultimately, no matter which method you use, there will be a way to eventually have your compound in a fairly pure state, for lack of a better word. Here, pure is meaning in the absence of solvent. You can eliminate most of the solvent from your mixture and end up with your plant extract. But that's 2/3 of the battle. On top of that, then you have to say, well, do we really have what we want? And do we have it in the right amount? And that's where analysis comes in. You might use GC, gas chromatography, or HPLC, high pressure liquid chromatography, depending on your type of compound. If it readily vaporizes, then you're going to have GC at your disposal, because then you can vaporize it and see what happens. If it's a pretty non-volatile liquid, then that's not going to work. You might end up burning the material, if anything. So then you go to HPLC, where you say, okay, well, let's put it in a liquid solvent and separate the components of the extract that way. Here you're looking for unwanted material. You know, plant extracts, you might extract some other things. For example, if you want your cannabinoids, well, that's fine, but it's a plant. So you might end up with some chlorophyll or xanthophyll and any other pigments. You might not want that in your product. So then analysis will tell you if you have any pigments, for example. Otherwise, the bigger concern might be your solvents. Again, do you want paint thinner in your plant extract? The answer is no. So there's that practicality aspect, and there's sort of a QA/QC element to it. If you have your plant extract, but then you see I've got some of the solvent in there, then it just goes back to the distillation phase. Maybe you change from a simple distillation, if you did that before, to a fractional distillation to try to coax it out. Otherwise, if you're solvent free at the end, then you have to say, well, are there any harmful compounds that have been extracted as well? Any deleterious effects from, say, unwanted plant metabolites. You don't want that in your product, because then you take the product and apply it in some way, and adverse effects can happen. So it's not just being a technician in the sense that, well, you just do it. There's a lot to be done and a lot to look out for. And the researchers can come in quite handily, because then the technician will say, okay, we can get this far, but there's still some impurities. It's not ready for market. And then the researchers have to go back to the bench and say, okay, let's take some samples and sort this out further. And so they refine their methods. And as this process goes on and on, eventually you work out all of these kinks, if you will, in the process. And then you do get to a more industrial scale where now you can work instead of maybe on a 500 milliliter scale. Now you're looking at scales as large as 20 liters. If you've ever worked inside of a fume hood, you can appreciate what a fume hood is. Once the glassware scales to a certain size, fume hoods become entire rooms, where now you're no longer pulling down the sash to keep your reaction vapors from escaping. Now you're walking into a room with a huge flask, and you're doing things on a very large scale. Once you get to that point, it's a lot more of a technician's job than a research job.
So, you heard my lab instructor, Paul Savoy, Dr. Paul Savoy, say that one of the possible things that you could be using in cannabis extraction is a roto evaporator, and then he also spoke of fractional distillation. Well, after you will be seeing after this video here, you will be seeing pictures from my own lab in organic chemistry of my fractional distillation of the separation of caffeine from tea using methylene chloride as our solvent. Like in cannabis, how you would either use ethanol or propanol or butanol as your solvent to extract the cannabis or the THC. I used methylene chloride to extract the caffeine from tea. And you'll also be seeing the roto evaporator as well as my caffeine in the caffeine in the roto evaporator as my experiment's going on. Thank you. So, thank you so much for watching and listening to this very in-depth video about cannabis extraction and the life of a cannabis extraction technician. Um, Also, just to explain the previous picture a little bit, in my separatory funnel of my liquid extraction, uh, the top brown part was the tea, and the bottom clear, the bottom opaque like white part was the caffeine and the methylene chloride solvent. So the second picture was the roto evaporator, and the third video was my caffeine experiment spinning in the roto evaporator, evaporating off the methylene chloride. So again, thank you for watching. Appreciate it. I'd love a good grade on this. Yeah, I'd love a good one, Mr. Frank. I'd love a good, great grade. You have a good one.